Hello everyone. Today we're going to learn how to construct a schematic circuit or logic circuit on multisim. So let's say I'm going to look online for an example. Let's say digital circuit. Okay, so I'm going to take a simple one. Yeah, this one. We took all the gates here. So this is a 3-input circuit, X, Y, and Z. And I have an OR gate, XOR gate, NOT, OR gate, and an XOR gate. So I want to realize this circuit on the software, and I want to build or construct the truth table of this circuit. So for now, let's build the components. So we have 3 inputs. Now we'll go to the Multisim software. So you see the menu here. The last one on the bottom here, it's my digital, let's say, domain. So here is my digital constant. That's an AND gate, or NAND, NOR, XOR, XNOR. You have a buffer. We never use the buffer actually. And there is the inverter, which is the NOT gate. So I want my inputs, X, Y, and Z. So this is the first one, second, and third. Now for each one of them, let's say rename it. So you can do this by double click. Okay, that is X, that is Y, and that is Z. So I have my 3 inputs. So let's go back to the circuit. So I have an OR gate between X and Y. So we'll go to the OR gate here, and it has many, let's say, shapes. There is the 2-input OR, 3-input OR, all the way to 8-input OR. In our case, it's a simple one. It's a 2-input OR between X and Y. Let me just confirm, yeah, X and Y. So it's pretty much like connecting any circuit component we covered in the class. And there you go. So we have X and Y. They are ORed with a gate. Now there is an XOR gate between Y and Z. So we'll go here. We have an XOR, again a 2-input XOR between Y and Z. So there you go, that is Y, and this is Z. Let me just confirm. Yeah, Y and Z. And there is a NOT for the X. So here X, there is a NOT. So I'm gonna put a NOT gate or an inverter. And that is alone for X. Connected, there you go. Don't worry about the shape. The most thing that matters is that the circuit works. And the output of the XOR and the NOT gates, they are OR together. So I need a 2-input OR. I can hear. Okay, so there is the OR gate, and the final answer, or let's say the final gate, is the XOR between the output of this OR gate and this OR gate. So I need an XOR. XOR. Go back. 2-input XOR. All right. So the circuit is done, and here is the output. Now for the output, usually, like, you will not find anything here. Now, usually for the output, we need an indicator, and the best indicator here are LEDs. So we need like a basic LED circuit. So this one here in the diodes, and you'll find LED, a light emitting diode. So you have to connect it. And along with LED, I believe you need to connect a resistor of a small value. It's pretty much like connecting any circuit. And in the end, you need a ground. So basically the output of this one is either digital 0 or digital 1. However, this is like in digital domain. But when it comes to real life, digital 0, that means 0 volt. Digital 1, usually it means 5 volt. So if I want to see that there is a digital 1, so there will be 5 volt, and there will be a current that passes the LED, and it will make it light on. So that's the logic of connecting the LED. Usually LEDs are indicators. So let me connect this components here. Okay. And this LED, actually, when you double click, there is a color. You can change it, blue, green, red, whatever. So I'm going to keep it red for simplicity. And for the, like for this resistor, let's keep it for 1 kilo ohm. And we have the circuit. So let's see how the output will look like. So when you run, now notice here, everything is written 1, 1, 1. So when you click, it should flip. That is a logic 0, a logic 0, a logic 0. So to build the truth table in this case, so we start from all zeros. So let me stop the simulation. I'm going to bring Microsoft Word here and we'll teach you how to build a truth table. So we have 3 inputs. Okay, go here. We have 3 inputs here, X, Y, and Z. So how many combinations will be 2 to the power 3? I'm going to have 8 combinations from 0, 0, 0 to all ones. So we'll go to the table here, insert a table. So I'm going to have 3 columns for the inputs and the 4th column for the outputs. And I will have, for now, let's keep it 8. So here is X, here is Y, and here is Z, and here is the output. Let me just put everything in the middle to make it more, let's say, presentable. So to fill the truth table, the best way, start from the last column or the one near to the output or the least significant bit. Do it like this: 0, 1, 0, 1, 0, 1, 0, and I think I'm missing 1 row. 1. That's for the first column. Now the second column is going to be 0, 0, 1, 1, 0, 0, 1, 1. And the last one is going to be all zeros, 4, and the last ones are 1s. So let's keep everything in the middle. There we go. And let me just modify the shapes, the columns. All right. So here is the table. I have all combinations 0, 0, 0. That is equivalent to 1. If you like, you can insert a column to the right, to the left, sorry. And let's call it sequence number. And you start from 0, 1, 2, 3, 4, 5, 6, 7. So we have all these. We have 8 combinations. We start from 0, which is equivalent to all zeros. Let's say number 4, it's 1, 0, 0. And so basically the sequence is the actual number, the index number. And X, Y, Z is a binary combination of that number. So this one is good to track your inputs. So you will not miss any of the combinations. And you have the table here. So let's see what will happen when you have all zeros. So we'll go back to the circuit here. So I'm having all zeros here. You can see the number 0. So just run. Okay. You see the LED is on. It's red color. So in this case, I'll go here. I will put 1. Now I'll try X0, Y0, Z is 1. Go here. Now Z is 1. The output, it's still red. The circuit's still running. You can do the switches and the circuit's still running. So I'll go here, you put 1. Now let's try the case 0, 1, 0. So put it back here, 0, 1, 0. That's X0, Y is 1, Z is 0. And the output here, you see that the LED is off, it's not red. So you'll put 0 here. You have 0, 1, 1. Okay, the LED is still off. That is 0. And so on. You keep doing that until you fill the truth table. And this is what is required from your task. So let me open the handout for logic circuits. Okay, so basically I'm gonna give you this expression. So it has 4 inputs, A, B, C, D. First, you have to come up with the circuit. You have to draw the circuit for this expression. So we have an AND gate, there is an OR, there is inverter, B bar, A bar, and there is this XOR. So basically it covers all the gates we did in the class. Do the circuit, realize it, do the, let's say, the schematic here. Don't forget to add the LED and the resistor at the end for indication if there is an output or not. Let me see if you reduce this one to 500, you get higher current. Okay. Okay, so it's more brighter actually with this resistance. So for this circuit, let's do a red LED and let's keep the resistance of 500 ohm to get a brighter light. So what you need to submit this circuit, this run. Once you save it, the URL, and fill the truth table for this one. Remember, we have 4 inputs, so you're gonna have 16 combinations, starting from 0, ending at 15. Let's say you have 1 week to submit the lab. I understand it's gonna be a vacation. We have a long holiday. But let's try to finish everything as soon as possible so I can release the totals before the final exam. So that's it for today. If you have any questions, feel free to ask me, either Telegram or email. And actually, I say I'm more responsive to emails than Telegram. Telegram is really hard for me to catch up, and emails is better. So send me on email. If you have any inquiries, send me on email. So let's stop the recording.